guys, Mrs. Traver here. Today we're going to talk domain and range. Let's jump in. Our learning target is you'll be able to recognize domain and range from a function on a graph or a table, and you'll be successful when you can describe difference between inputs and outputs. Today we're going to talk about the quiz and see how that went. We'll look at the graphing assignment from yesterday, as well as take notes on functions, domain, and range, and have an assignment after that. So real quick, just a couple mentions on the quiz. There are several of you who were absent for it when it was done in class. Watch out for the email on when to make that up. I will not be doing times other than the class period you are in or the makeup time. So you need to make sure you are on time and there for the quiz or test. Thank you to those of you who were. I appreciate it. Look at your notes if you're the ones who have already got it done. Look at the notes on Student View so you can see the notes that I went with your assignment for the quiz and for the weekly assignment last week. Next, the graphing assignment that was posted where it said mixed graphing practice worksheet. That is not part of next week's homework check. I'm actually taking off the submit here link for Monday, so you don't have to worry too much about that, but it is good practice if you're looking forward to potentially needing some extra help on graphing stuff. Okay, with those two things out of the way, let's jump in and look at our notes on functions. So we've got this idea that we've kind of seen a couple times with the vending machine, and it's a good representation of inputs and outputs. For example, with a vending machine, you put in like a 14, for example, and you get out a candy, a specific candy that you chose. In a function, you put in an x and you get out a y, or you get out an f of x, depending on how you want to look at it. Either of these are okay for x's. Now with functions, there is this rule that says there's exactly one output for each input. We took notes on this definition of functions last week. Moving forward, let's try some examples with functions. So here's a picture of one, and I want to estimate y when x is -4. So x being -4 would be on this line, and y is right here at that time. It says estimate, so I'm going to do kind of like a roundabout. I'm going to erase this little bit here because it was kind of hard to see. Whoops, too far, so sorry. So it was right about here, so that looks like, what height? Less than -4, maybe 3.75, maybe -3.75. So we're estimating the height of it. Let's estimate y, or the height, when x is 4. So that'd be right here. I'm going to say that's pretty dead on 0. So I'm going to say that that's about 0. And estimate y when x is 1. So when x is 1, ooh, it shows up in two places. It shows up here at 2, and it also shows up down here at -3. Is the relationship a function is what it asks us. So remember on our last slide we said a function is when every output has one input. Exactly one output for each input. Notice on this one, this output had 2 inputs. So then therefore it is not a function. All right, let's try another. This one, it doesn't look like a graph. Instead, it looks like a function machine, or just in function notation. So it says, what do we put in for x if we get out something else? So in this case, what if we put in a -3? So in that case, I'd have, instead of 6 over x minus 3, I'd have 6 over -3 minus 3. And now we can work this out. -3 minus 3 is -6, and I can simplify to get a -1. So f of -3 is -1 on that one. Let's try it with 0. I have 6 over 0 minus 3, which simplifies to 6 over -3, and 6 divided by -3 is -2. So I have f of 0 is -2. 2 more. F of 2, I've got 6 over 2 minus 3, simplifies to 6 over -1, or -6 for f of 2. If I try it with 3, I've got 6 over 3 minus 3. 3 minus 3 is 0. This one is undefined. You can't divide by 0. As a reminder on when you can divide by 0, when you can't, it is not okay to divide by 0. It is okay to have a 0 on top. So this one is the no situation, so it's undefined. Or we could say no solution. Either are okay with me. All right, I know I went fast. Remember, you can pause this as an online student and go back and watch it as many times as you wish. Let's talk domain and range now. So domain and range are two titles that kind of have a lot of different ways to think about it. Domain is the set of inputs, all the inputs you can put inside a function, and range is all the stuff you're going to get out from those inputs. Usually we talk about domain as x's and range as y's, or f of x's. So this is kind of our mindset for the problems we're going to move forward. Let's see what this one looks like. Whoops. So let's talk domain and range on this guy. Domain is everything we put into the function. So that's the x's. So notice the x's go from -2 up to 4. So from -2 up to 4, and it includes -2 because there's a dot there, and it includes -4 because there's a dot there. And how I'm going to show this is I'm going to show this as a set of numbers from -2 to 4, just like that. This says all the numbers between -2 and 4. Notice I use brackets because these points were included in that. Now let's look at range. Actually, I'll do that in a different color. Whoops, I keep doing that. Let's go red for range. So for range, it's how tall it went. So the lowest point here was, that looks like -1 to me, I think, from here all the way up to here. So that was from -1 up to 3. From -1 up to 3. And it looks like it hit it on -1 and it hit it up on 3. So again, I'm going to say brackets around that -1 to 3. All right, let's look at some that don't have brackets next. I've got 6 more, lots of them here. So I'm going to spin through and we're going to talk domain and range for each one. And let's jump in. So let's do all the domains first so we can get them in our head. Domains are x's, so it goes from -4 up to, wait, that's not -4, that's -3. From -3 up to 3, and it includes those numbers. This guy, let's see, the domain goes, notice the arrows? So this actually goes on and on and on forever in the left and on and on and on forever in the right. So in that case, because it goes on and on forever in both of those cases, what we can actually just say for it is all real numbers. Sometimes you see it written like this. This symbol means real numbers. So either of those are okay. I kind of ran out of room for C, so I'm going to do it up here. Domain. Look at this one. It goes from this spot, which looks like -2, all the way up to this spot, which is at 4. So from -2 to 4, including both of those, so brackets. Let's try this parabola. It goes from, it goes on and on forever in both of those ends, left and right. So I'm going to say it goes all real numbers again. All real. Domain for this little squiggle, let's see, the farthest left point is here at 2, and it goes up to the farthest right point is 4. So from 2 to 4. And then our last one here, we're going from, let's see, from 0 all the way up to forever and ever. So this one's a little bit different than the other ones we've seen. It goes from 0 up forever and ever. What do we call forever and ever? Infinity. If you thought of that, awesome. Give yourself a pat on the back. So this one for a domain, I had to rewrite it. It goes from 0, and it includes 0, and it goes up to infinity, but you can never actually like touch infinity. So I don't want to put a closed bracket there. Instead, I'm going to put a parentheses to show that we're just reaching for infinity, but we can't actually touch it. So parentheses go with the infinity signs. Let's do all of these again now, but with range. So red for range. Range is up, down. This one goes from -3 up to 3 for a height. All right, this guy goes from -infinity up to +infinity. So for this one, the range is all real again. For this segmented line, it goes from the lowest point is -4 up to the highest point is 2. So the range from -4 to 2. For the parabola, the highest point is right here at 4. And it, oh, you know what I should do? I should go from bottom to top. Let's say the lowest point on this graph is down here at -infinity. And it goes up and it stops at, all right, and then on this guy, let's see, our range is the lowest point -3 up to 2. So from -3 to 2, including both of those. And then our last one here, it started at 1, 2, 3, started at a height of 3, and it went up and up forever. So it went from 3, including it, up and up forever. All right, that was a ton of domain and range practice. Let's move forward here to some tables. Domain in these cases are the x's and range are the y's. So if I was going to talk about the domain of this one, I would literally just say it's the set of all of these numbers. -3, -2, -1, 0, 1, 2, 3. And if I was going to talk the range, I would say the same thing, but the set of numbers in the range. So I'm going to go least to greatest, -4, -3, 0, 5. Now notice I didn't do any repeats. We shouldn't in a set. For this guy, the domain are all the numbers in the x column. -2, -1, 0, 1, 2, 3, 4, and 5. And for the range, let's go least to greatest, starting with 0, 1, 4, 9, and 16. And notice again, I didn't do any repeats. So if you've got a table, that's what you can work with. We are ready for our assignment at this point. Let's look at section 125, numbers 78 through 82. It is already up on my screen if I can get it. So if we scroll down to review preview, here it is. Number 78 is talking about some more of those functions or not. So tell me if it's a function or not. You've got some plug in X and see what happens. If you have any questions on today's assignment, please come see me on Zoom. I've got lots of you not taking advantage of that. So I hope to see you there. Again, look out for the email if you missed our quiz. You need to make sure you're working on being on time for those so you don't have to keep making them up. I will see you next time.